I'm always rushing. You'd think I'd have enough time to organise all this in advance. Why's my head so big up there? The top of OBS is like super zoomed. I don't really need that, do I? No, it looks okay over there. That's fine. Good morning. I'm rushing a little bit. Where are we now? 5:30 a.m. So it's and I've been up for an hour and a half. We're traveling. Today is a travel day, hence the super early start. I've got to get rid of my head from there. It looks massive. That's better. It's a super early start. Nowhere exotic today. Off to Sydney. So, Sydney, for those of you from other parts of the world, you'll know about Sydney. Australia's a lot bigger than just Sydney, as it turns out. We live, what are we, about an hour 20 flight or something? So it's handy. But we had various things come up in Sydney all at once. So today we're going to go and spend a bit of time with one of our consumers of have been pwned things. Next week we've got some law enforcement meetings with folks from a couple of different parts of the world, which is always really interesting. I like those meetings. It's cool because you never know exactly what's going to come up. Anyway, we'll see if there's anything out of that I can talk about later on. Wayne, James, Null Division, the game is over. Yeah, g'day. Welcome. Welcome to 5:30 a.m. on the Gold Coast. One of the weird things about Australia, many weird things, is keeping in mind Australia is about the size of Europe or continental US. We got lots of time zones, which is fine. But in most parts of the world, when you go up and down the country, the time zones stay the same. When you go left and right, I forget which one's left and long, they change. For reasons that are still not entirely clear, we don't have daylight saving in our state, in Queensland, but 30 kilometres due south, New South Wales, the state that Sydney is in, they have daylight saving. So you get a roughly half the year where everyone there is an hour later than everyone here. And the border actually goes down the middle of a street in a town, a fairly sizable town. So you've got one side of the road that right now is 5:33 in the morning for me, and the other side of the road is 6:33. And it also means when we go to Sydney on a day like today, it's like you look at my trip and it's like, okay, we need to leave soon, but then we land after lunch. What? Oh, yeah, because it's an hour. And fortunately, I don't have to go to an office or do stuff like that anymore. But if I had to go to Sydney for a day in the past, it's very hard to leave here in the morning and be there for 9 a.m. For half the year because of the daylight saving thing. So, yeah. Anyway, fun, useless Australian trivia. Apparently, it's something to do with either confusing the cows or fading the curtains or some bullshit reason like this. So we don't have daylight saving. Johnny Doc's in the UK. I'm actually off to Sydney in a few weeks. Looking forward to it. Sydney's a nice city. It is. I don't mind going to Sydney. Melbourne, not as much. Sydney's all right. And James says AU has 30-minute time zones, which seems strange to some of us. Yeah, so that's a bit of a mess as well. So I think South Australia and the Northern Territory are 30 minutes behind us. So you know how when you're trying to communicate with people somewhere else on a different time, the other side of the world, and you're like, so are we going to meet on the hour? It's like, well, it's not the same way everywhere. It doesn't work the same way everywhere, which makes it a little bit messy. Yeah, like James says, boss, you're an hour late. Employee, no, I'm working from home across the street. But this is what it's like for families down there. And a lot of the argument that people have made for years and years and years about why our state here, Queensland, should have daylight saving is that particularly when you're on, I was going to say border towns. There's really only one border town because if you've ever seen the population distribution in Australia, we're pretty much all on the coast and pretty much all on the eastern side with a few exceptions. So there's one town down Tweed Heads, like on the coast. There's a bunch of families that do work on one side and live on the other side, or the kids go to school on one side. There's probably kids where one kid goes to school on one side of the street and the other kid goes to school on the other side of the street, and you've got to coordinate around that. So that's, I don't know why we haven't changed that. It's just, it is a weird anachronism. Is that the word? Anyway, it's a weird thing. Steal the logs. So I was kind of thinking, what do I talk about early today? And I do have a big blog post coming on this. And so one of the things I'm going to be doing on this trip is finishing this blog post. But if you recall, last month, I think it was bang on the middle of last month, so probably, 5 weeks ago, we published some steal logs and they have been pwned, not unusual. There were, how many there? Like 220 million or something like that. I've got to get my facts right here. But for the first time ever, not only did we publish the email addresses, but we published a mapping of the email addresses to the website domains. Now, I'm using my words really carefully here, and we've spent the better part of the last month working on a lot of this terminology. I'll look for million. I think it was 220 million unique rows. Now, just keep these numbers in mind because you'll realize how big this last set is. Last month, 220 million unique rows of email address domain pair covering 69 million of the total 71 million email addresses in the data. So what tends to happen with that set and the set I'm going to talk about in a moment is that you've got a truckload, I was going to say something else. You've got a truckload of text files. And in the case of what we're going to talk about today, let me get my numbers right. I think it's 744 because I've been looking at this nonstop for the last month. We have 744 text files. And as I've spoken about stealer logs before, the stealer logs are the URL that was in the address bar when the infected person entered, so that's part one, their email address and the password, so there's 3 parts. Now, we use our email extractor tool just to go in there and grab email addresses out of text files. Totally indiscriminate. So for a classic, you know what I mean, normal data breach, it might be somewhere within that normal data breach, you've got a couple of million rows of user records, and every row has the username, the IP address, and the email address, and it just picks it up beautifully. If somewhere else further down, there's also DMs, and in the DM, there's another email address that appears, then that gets all bundled in because it is in the data breach as well. Context is different, but still in the data breach. So we run the email addresses through there, and we pick these up. So we had 71 million last time. Now the stealer logs, when we went through and we picked up the individual instances of email address against the domain of the website that they're logging into, we don't do the full URL. So if you're like spotify.com/oauth/login/hashbang blah 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 blah, you just get spotify.com. When we grabbed all of those 220 million unique rows of domain and email address, there was 69 million email addresses in there. Now the gap between the 69 million and the 71 million was that there were some email addresses in the stealer logs that didn't sit cleanly against a URL, email, password triplet. So 220 million rows, 71 million email addresses, 69 million of which were against a URL that we could extract. Now, the data that I've just been dealing with, and then we'll talk about the challenges of dealing with this much data. 1.5 terabytes worth of text files, 744 files. There are 789 million unique email address and domain pairs. So it's 220 in the last lot. 789 million, 284 million unique email addresses. 244 million passwords that we've never seen before have gone into Pwned passwords. And 199 million passwords that we had seen before have had their counts updated. Now, this is not all live yet. This is going live next week. We're just on the final stage of the processing verification. And I thought, given I wasn't sure what else to talk about today, and I did kind of rush it this morning, we'd just go through what was involved in processing this because it is nuts. I think in the blog post, I'll give a little bit more background about how I came across this. And it was someone from a government somewhere was like, look, have a look at this. And they sent me these 2 files. And I was like, there's a substantial amount of new stuff in here. It's obviously legitimate. And I started going through the load process to have it been pwned. And then as I was doing the verification, I was looking into it more and pulling the threads, and I found the stash of the larger corpus. And then I was like, okay, well, now I've got to go and grab all the data. This will be fine. So how do you deal with that much data? There's a point in this blog post where I'm trying to solve it in the cloud. And I was like, that the cloud was not the solution. And let me just maybe run through the mechanics of it. So a lot of this is just custom written code to try and do things as efficiently as we can with really large amounts of data. So one of the things we have to do with a corpus like this is extract all the email addresses. Now, there is an open source email extractor tool to do this. For 1.5 terabytes worth of data as 744 files, I think it took somewhere in the order of a day. Actually, I'll rephrase that. We got to about 3/4 of a day before it crashed. Now, the reason it crashed, and just the number of times I had to say to Charlotte, look, we just paid for a bunch of cloud, or a bunch of time has been burned, only to discover that this wasn't going to work. The reason it crashed is that there is one line in one of the files that caused an out-of-memory exception for the .NET app that was reading it. Because there is one line that is so long, it crashed the code. And unless you're actually wrapping that in a try-catch to catch that exception where you run out of memory, everything just bombs out. Now, in the email extractor, the open source one, that wasn't obvious what was happening. It gobbles up that exception. In my own custom code to extract the stealer-log pairs, which I'll come back to in a moment, I was actually seeing the full exception message. Unfortunately, I ran into that exception before I ran into the other exception. So I end up getting to the point where we just had to stop reading the file. It's only one of 744. I think you can get 3/4 of the way through the file. Had to stop it on that exception. But that's the sort of thing that you get a long way down the road, hours and hours and hours and hours, and then it just crashes, and effectively all that work gets unwound because it buffers up all of the email addresses it finds in memory, and when it gets to the end of it, then it writes it all out to the file to be efficient, which is a problem. So Stefan says lots of storage space and RAM is how you deal with it. So Stefan, I put on that, and in fact anyone can see this, github.com/have I been pwned. There's a repo, I think it's called email extractor. I have raised an issue in there. Stefan, if you want to see the actual file, I think I remember which one it is, and I'll send it to you and you can see it. But yeah, it crashed out. Right, so we can get the email addresses out eventually. But the other thing that we need to get out is the passwords. Now, the passwords, when a stealer log has a predictable pattern, the 3 parts we've discussed before, the URL, the email address, the password, you can read a line. You can split based on a colon. So long as there are 3 parts, then it's considered valid. And then you take the last part, and that's the password. But then just to be safe, we've got a little bit of validation in there, which says, if this is an email address, discard it. Because sometimes stuff gets messed up. And incidentally, this is one of the reasons we store passwords in Have I Been Pwned as hashes, so that if the parsing does screw up and you end up with like the whole line with the URL and the email address and the password, or even if you just end up with the email address, you're not then redistributing PII. So if people go and download all of these passwords and there's a bad parsing issue in there and you've got someone's PII, that's a bad thing. If it's an entirely hashed line, then it's got a level of protection that's probably not going to be broken unless you're trying to crack hashes and somehow you manage to guess the entire unparsed line, which is extraordinarily unlikely. Wayne says maybe local box or VM, run it through locally to ensure it works, then run in Azure. Well, I'll come back to the stuff we've tried to run in Azure and what didn't work. So the password's not too much for drama. But the other thing is that we need to then, separately to that, get out, because we're now loading domain and email pairs, we need to get those 2 out together. So another little console app I've written goes through, same thing, looks for the 3 parts, and then it looks for the first part. Is it a domain that passes, or rather, is it a URL with a domain that passes some basic validation? And that validation includes things like there's a regex for domain, there's a TLD validator, is it on a valid TLD? And then the same sort of thing for the email address. It validates the domain part with the same logic, and the alias has got another regex and effectively a max length to it. And that's it. Now, That sounds easy. So you run this, and for every file it goes through, and it creates two files. It creates one file with all the valid entries and one file with all the invalid entries. And I did this because I wanted to see what was being rejected, to see if I was false positiving any stuff. So now I've ended up with one file of this is all the stuff we're going to discard, one file of all the good stuff, 744 times. So this is where we ended up with 744 files that had 789 million. I'm going to rephrase that because it's actually more than that. We ended up for each file with a distinct email address and domain for each file. But it turns out there's a lot of redundancy across the files. So at some point in time, you've got to dedupe that redundancy. It's too much data to just do the whole thing in memory, or so I thought. That's where I started. So got all this data sitting there in text file. We've got to get it into SQL Server in Azure. So it ended up being, I think I was running it at night, compressing this stuff. You can compress it down pretty well, but then you're trading off. It's like, okay, I've got to get it up to the cloud. I'm trading off the time it takes to compress with the gain that's made by uploading a compressed file versus how fast is my internet connection if I just drop it all in a synced folder and only I can access it on a VM in Azure, which is what I did. And then you got to get 744 files with a lot of hundreds of millions of rows into SQL Azure. So SQL BCP is very fast at this. So you can run SQL BCP and it picks up a file with a delimiter and it drops it in a target table. It's dumb. It doesn't do any transformations along the way, but so long as your data is structured and consistent and it goes into columns that match, you're good. So we do that, and that takes about a day, even when you're there on the local network from a virtual machine into a SQL Server database on the same network. So I did all that, and then went, okay, well, that's cool. So now we've got the website domain and you've got the email address. But to get it into the data structure that we're moving towards, we need to split that email address into alias and domain pairs. And we also need to get a unique set of website domain and email address. Now, SQL is very good at doing unique. So you got a distinct clause. So we can say, well, distinct operator, you know what I mean? So we can just say, select star from stealer-log, and instead of that, it's like select distinct website domain and email address from stealer-log, job done, no problems. And it's a big data set. So I scale Azure all the way up to 80 cores on hyperscale. Now, 80 cores on hyperscale is costing us, I think, 800 something Aussie dollars a day. So let's call it nearly 600 US dollars a day, which is not fun, but it's short term. And we do charge for keys and some other services, so we can kind of justify it. So you turn the knob all the way up, and then you start running the query. And then you wait. A day goes by. And you don't have any idea how long a query is going to take as well. And I've got my big chart of graphs and everything up on the wall, and I'm just looking at it sitting. It's back down to 4 now, but it was sitting at like 80 cores. But the CPU percentage wasn't high, and I'm trying to find some sort of metric to show that there's progress. Oh, the space used. I can see the space used is changing through some of the processing because we're selecting out of one table, selecting a distinct into another table. We're just trying to like filter down, start the funnel wide and filter it down into smaller and smaller data sets. But long story short, we ended up getting through it. I think we got through to about 2 days and we've now burned $1.5 Aussie $1,000 worth of money on SQL Server cores. It hasn't finished. There's no indication when it will finish. So I ended up realizing that turned out to be much more efficient to go all the way back to .NET code and just do it locally in .NET rather than trying to do it up on the cloud. Now, not only locally in .NET, but doing it on this machine. I found a spare 10 terabyte disk laying around, chucked that in the machine, managed to get all the uniques out, then the same job again, into a synced folder, up into the virtual machine, SQL BCP, into the database. Managed to get all the unique domains out of that as well because we've got domain as a foreign key into a table in Azure. So we need to get a list of all of the domains that are in these stealer logs, and then all of the ones we haven't seen before, and then there are something like 6 million domains that we hadn't seen before. We've got about, I think, 300 million in the table. Incidentally, a domain includes a subdomain. So you get a lot of very unique subdomains in these exceptions. all those go into the table. And where we're at now is we've got, what did I say it was? We've got 789 million rows in one table that have the website domain, the email alias, and the email domain. And what we have to do over this weekend is scale it all the way back up to 80 cores, load the 284 million unique email addresses like a normal data breach. That'll take, I don't know how long, maybe half a day. Load that like a normal data breach. And then we need to insert the 789 million records into the stealer log mapping table that maps a domain to a breached email address. Breached email address has now been populated because we've loaded that breach, not made it live, just loaded the breach. So we need to get a distinct out of the 789 million where the domain and email address have not been seen in the previous set of stealer logs. And I worry that that's going to take multiple days. And if I screw it up, I can burn multiple days with nothing having happened and then have to roll it back. That sounds long and laborious, and it misses about 90% of what I had to do. At one point in time, after realizing that trying to query the entire corpus of email address and domain pairs was a futile effort, and I had to cancel it. I thought, you know what I'll do? I'll try and batch it. So what if we try and batch it? And we just process like 1 million at a time, and we just iterate through. And I spent a couple of hours writing the code to do this, testing it locally. And while I was doing that, I thought, well, what I'll do is I'll drop an ID column onto the data that had already been loaded. ID, auto incrementing number. That took about a day and a half to run. It took our storage it went from like 2 terabytes up to 4 terabytes something to add a column. I've got to screen grab this because I'm going to put it in the blog post. It's ridiculous. Just to add this column. I got to find the image now. This was nuts. Data storage size. Here we go. Not for the last 24 hours, but we're going to do this for the last week, because that's how long I've been mucking around with this stuff for. Is that the right thing? Am I on the right database? Data storage size. Maybe it was capacity or used or something like that. Data space used. That's what we're after. Yeah, so I got this really wild chart now where it's like, normally we're using about 1 terabyte worth of data. And then I SQL BCP up a bunch of it, and it goes like this. But I had to do it in 2 parts, so it flatlines a bit while I wait for the next part. And then it goes like this. And then it flatlines for ages while I'm realizing the fact that I just can't run this distinct query, and I drop in this auto incrementing column. And then we've gone from like, where were we? We're like 994 gigabytes worth of space used to SQL BCP everything up. Now we're at 2 terabytes. We add a column. We go from 2 terabytes up to 3.7 terabytes, and then it sits flat for a while. And then this is just like an alter table, add column kind of thing. And then it goes all the way up to 4.6 terabytes, and then suddenly it drops from 4.6 terabytes down to 1.9 terabytes, which is roughly where it's sitting now. And all the while, I'm just like feeding money into the Azure machine. Anyway, the sort of lesson I learned on that was to do as much local processing as possible in .NET. And the relational database stuff is great for queries and joins and things like this, but for actually filtering down the data, it was just a bad idea. And so I think somewhere in this blog post, I've made the comment that the cloud is not the solution to all your problems. And so many times, even when I've been talking about getting, speccing a computer, you know, I try and spec computers pretty high. And people go, why are you doing that? Why don't you just do it all in the cloud? There's loads and loads of stuff, which is fantastic about the cloud, and loads of stuff that's a nightmare. I'm going to screen grab this graph now. I'm going to put that in the blog post, because I can see it's like a roller coaster of emotions as all the capacity is used. And I can just see you get charged based on the number of cores you're running and also based on the amount of storage. How much did this end up costing me? I mean, normally our database runs pretty efficiently. Drop that in the blog post there. but I have been a bit scared to look. Now, actually, that reminds me. So I'll talk about what we want to do with some pricing stuff as well. And Charlotte sort of should talk about it here and get people's opinions and see if this sounds reasonable and sensible. Where's my dashboard? So while we're running those big instances, okay, that was a bit more than I thought. That was Aussie dollars. So take off about a third for American dollars. One day was $1,026. Another day was $1,049. Another day was $944. But normally we would be running at $100 something for a day of SQL Azure to support the 14 odd billion records and the gazillion requests we get every day. So normally it's pretty good. The last few days, not so much. Let me look at the comments and then I'll talk about how we want to try and structure this. Daylight saving stuff. I think we just want to make everything as fast as we can. Look at like we want fast internet. Internet's actually pretty good here in Australia now. We do get reliable gigabit down. I get about 400 megabits up, which for most what we do is really good. James says, where I live, often your upload is way slower than download. Yeah, exactly. Yep, you don't have that quite that parity. James says, doing a look at the email extractor part. I'm curious what you determined is a valid email. So one of the things, mental note, Stefan, one of the things we have to do is we don't yet have consistent logic across every point in the app about what makes a valid email address. But have a look at the email extractor app and have a look at the issues. There's a lot of discussion there. It is impossible to write a regex which meets the RFC for an email address, and it doesn't matter. And the reason it doesn't matter is that how many people struggle with even slight but valid variations of email addresses? So I know a lot of people struggle with various websites that won't accept, say, a plus in the alias, which is perfectly valid and useful, and a lot of people use it for subaddressing. So when you get to weird things like you can have another @ symbol in the alias so long as it's escaped or something to that effect, no one's legitimately using that. Like your life would be miserable trying to enter that email address into places. So we have to strike this balance where things like non-alphanumeric characters and other than, I think, a dash and maybe an underscore and a dot and a plus are not valid in the alias. And we've just then got to do that consistently everywhere. And it doesn't matter if we have a false positive because we've then got this, let's say in this case, hundreds of millions of email addresses. If one gets excluded because it's this valid, weird syntax that one strange person uses somewhere that managed to accept it in a website, it doesn't matter if that's not included. So we're trying to weed out the junk and keep the legitimate stuff as much as possible. But have a look at that repo. There's lots of discussion in there. And in fact, that repository does need to have an update because when I look at the email addresses that get extracted out of data, there's still a bit of junk in there. And when I say a bit of junk, it's like a tiny fraction of 1%. And nothing too bad happens if the junk goes in either. But it would be nice to have as little as possible. Yeah, so Wayne, to your suggestion, maybe a local box or VM, run it through locally to ensure it works, run it in Azure. Yeah, even these queries that can take days to run, do you want to run it locally for days and then have to run it remotely? I think the overarching theme is filter and minimize as much as possible locally and get the cleanest set possible up into SQL Azure. And what the cleanest set possible means is that when we upload the email addresses, it's like any data breach, just email addresses. When we're dealing with the domains from Stealer logs, we just have a distinct set of domains. Then it has to go up into SQL Azure as the full distinct set, because then we need to see which ones we already have and which ones we don't. And of course, when we upload the Stealer logs themselves, the mapping between the websites and the email addresses, we have to get that entire mapping up there. But if we can just get a distinct list, then that's the smallest possible footprint we can have. And then the only thing we could do a little bit differently is try and save ourselves some joins later on, because when you end up with 789 million rows in a table and you've got website domain, email alias, email domain, you're basically doing 3 joins from 789 million records onto the other tables. Now, what we could do, and this is where you blow heaps of time and mental effort, we could add ID columns for the two domains. And then we could literally just go through and update that one table with one join onto the domain table for one column and then another join for the other column. You could run it as two separate queries. And that would help save the join when you do the big insert later on. It would help save two joins. But by doing two smaller queries now, will that be more efficient than... it does your head in. And every experiment costs $1,000. And I can't figure out a way to do that more efficiently. Anyway. What else we got here in the comments? Yeah, so Wayne's saying, yeah, I do what you suggested. James says, I found the part I wanted to look at for Man, I Hate Regex. Yeah, I know. I actually think we can simplify that a lot if we're a bit more brutal about excluding things that are spec compliant, but people just don't use. Wayne says, so it costs around 4K more than usual. Well, yeah, and that's just, yeah, pretty much, mate. So we will come back to the pricing thing in a moment because we've got to make this back somehow. Wayne says, make it a library and share it across the solution. In terms of email validation, now you can do that with all the .NET bits, but also on the SQL database side of things, we've got a couple of functions which validate the same thing, because there are times when we want to run that across data that's in SQL Server that hasn't already been run through that same logic outside of that. But yes, you are right. At the very least, we could have a maybe we should even just. I know Stefan had to go. If you listen to this later, Stefan, maybe we could just make this a standalone open source library, and it can go up into NuGet or something like that. That might be a good idea too. If anyone feels like doing that. James says, plus and dot are common. I added a dot to my sister's email address so she could create a second account on the site. So for those of you not getting what James is saying here, often the dot part of the alias is ignored. So if you're john@gmail.com, you could also be jo.hn@gmail.com, and that is viewed as a unique email address by websites, including Have I Been Pwned, but it's actually the same thing. I'm not sure that it is part of the RFC that the dot part of the alias gets ignored, or if it's just a Gmail implementation. Wayne says, automate it if it passes locally, send it for Jira. Yeah, and again, as a rough theme, that's true. The thing is, like the computer sitting here on my desk is effectively a sunk cost. The money's already been paid. I spec'd it pretty high. It's 5 years old now, but it's still a good machine. I was talking recently about getting another one. I think I'm just going to stick with this because it's actually, for the most part, doing everything I need. Using this to the fullest extent possible and getting the smallest amount of data possible up to the cloud for processing is the big lesson out of this. And I'll make a note. I'm going to make a note of that in here. Yeah, somewhere here. Yeah. I did say the cloud, my friends, is not always the answer. And I'm going to make another comment here. Do as much processing as possible locally. Yeah, and that's, I'm going to emphasize that. Neil says, morning, Alison, to catch you live. We're not in UK, currently heading down the road to Byron Bay. Now, make sure you take your Instagram to Byron Bay. My understanding of Byron Bay is unless you have Instagram, you will not get in, and you will have to post many inane photos of everything. Actually, we had a Norwegian friend visit us yesterday who'd been to Byron. I was saying Byron, I don't want to get completely off topic here, but Byron was really nice up until probably 2000, where it was sleepy and beautiful, and it's just been flooded for reasons I don't understand by tourists and celebrities and Instagrammers, and I vehemently dislike going there now. And I know a bunch of people that have left there. People like Patrick Gray, who does Risky Business, used to live there and moved out. I think a lot of it because of that sort of thing. And there's lots of nice, quiet places, but you'll have fun anyway. Wayne says, I think you can run C# and SQL Server. Not sure that works in Azure. Yeah, that's been there for a while, and I think there are some limitations with doing that in Azure. But if we distill this email address and domain validation logic, so there are two different bits here, and of course part of email address validation is domain validation as well. If we distill that down into simple rules, then it should be easy to have it in both. Matthew says, you'd end up finding a solution for your new light switches and IoT dimmer switches. I've had to go through a similar process. So, no, but the good money at the moment is on still having traditional light switches and Shelleys. Our Sparky has collected several different options, which he's going to bring over once we get back from this trip. And then we'll have a few different things on the wall. I'll post some photos. All right, let me move on with this. There's the next part of this steel log bit. You know, last month I wrote this blog post and said it's experimental. We're just seeing if it works well, loading this data up. That being the data that maps the email addresses and the websites. Now, it turns out it did work well. A lot of people found that really, really useful. A lot of people wanted more ways to query that. So, for example, we got a bunch of requests from organizations who are like, look, we run acmecore.com, and we would like to see the email addresses that have been entered against acmecore.com and then appear in the logs because they are our customers and they are having their accounts taken over. How can we get access to that data? And we have not done that before. The bit that we did do last time around, last month, is we made sure that if you're, I'll just pick Pfizer as an example, given my long tenure at the place. If you're InfoSec at Pfizer and you control Pfizer.com, then you could get a list of your Pfizer people. So troy.hunt@pfizer.com, as it used to be. You could get the list of those email addresses, but you could also get a list of which sites their data had been captured against, because effectively all that ties back to your domain. Now, a lot of what I've done, particularly as I've gotten to the tail end of all this processing, is to try and articulate the correct nomenclature about steel logs. And I've settled on website domain. So we've got a situation where we've got the website domain being if someone's logging onto Spotify and there's a great big string of path and crap after it, the website domain is spotify.com. You've then got the alias, let's say it's troy.hunt, we'll pick the Pfizer one, and the email domain, Pfizer.com. So we've got these three parts. So what we're wanting to do here is make available the ability for someone who controls the website domain of the Stealer log to see the email addresses that appear against it. And that's what we're going to do here. And the thinking, and this is what Charlotte said, talk about on the video, so what people think. The thinking at the moment is that the demographic that this is going to be relevant for is largely organizations running popular services that lots of people authenticate to, i.e. big websites. The top sites, in fact, you know what? I've got a list of the top sites here. I can read it. Now, this is the top sites. Here we go. So this is just some of the top sites from the last set of steel logs. So it's already in SQL Server, up in Azure, so I could query it. So the top sites are things like mega.nz, twitter.com, netflix.com, zoom.us, Discord. And it's fascinating to go through the list here. Wise, Wise, which used to be TransferWise, is transferring money. These all have tens or hundreds of thousands or millions, as of the last set of Stealer logs, before you get to this lot, of email addresses that appear against them. And what we want to do is we want to make that searchable. And what we thought we'd do is domain verification. So you've got, let's say it's Wise, for example. So you've got to demonstrate that you control wise.com. Now, if you can demonstrate that you control wise.com, at the moment, as of today, you can go and pull back all of the email addresses at wise.com and the data breach they've been in. What we want to do is create a Pwned 5, which is like a Pwned 4, but everything is double. Now, the domain size is always unlimited. The RPM would double, so it would go from 500 requests per minute to 1,000 requests per minute if you want to use the API. The cost would double, so it would go from, what are we at, 1,300 something US a year to like 2,600. And then if you have the Pwned 5, you would be able to say, give me a list of email addresses whose credentials are being captured via Stealer logs when logging onto wires.com. So that's the TLDR. You would need a Pwned 5, which is going to help pay for all the cloud, which we just spent processing this data. And also the ongoing storage, the cost doesn't stop once you finish the processing because you're still sitting on the data. So if you listen to this now, listen to it later on, and you have thoughts on this, is that reasonable and commensurate to say, create a Pwned 5, you need a Pwned 5 in order to search the email addresses entered against your domain that end up in Stealer logs? My gut feel, and this is the gut feel with all the pricing, it's not just gut feel, this comes back from people, is that we are very, very bad at pricing and everything is ridiculously cheap. And I'm quite okay with that. I think that's actually good because we want it to be accessible as well. But give me your thoughts on that. I'm drafting the blog post around that. We do actually have a Pwned 5 sitting there in the background that's just not visible on the Have I Been Pwned page. And we do also have a KB article, which effectively says if people want higher rate limits, let us know. Like, we can create these. We create products in Stripe and we create all the gubbins in Azure API management. So that's sitting in the background, but we'll bring it to the foreground. It'll sit there. You can choose that. And one of the features will be Stealer logs against your website domain. Okay, so we're at the comments here. Wayne says, have you seen that Shelley brought out switches covers for the relays? Yes. Oh no, other people can't post links here. I should change that. I wonder if I can change it somehow. Switches covers. Shelley switches covers. Can I just Google that? Will it come up? Shelley switches covers. Shelley switches can cover control covers and shutter. Oh no, that's the wrong thing. Drop me a cover on the Shelley website. Gen 2 cover. No, that's a different thing. Can you drop me a message somewhere? Who said that? What day is it? Where am I? Wayne. Yeah, drop me a message somewhere. I'd actually be kind of interested to see that, but I then see you say they're pretty basic. James says, the reason I like those is because they can run open firmware, and Martin Jerry will help even ship the open firmware. Is this about the Shelleys running open firmware? If it is, I have heard this discussion before. I know people run, I forget what the firmware is. I'm just not sure what else I need that the Shelley doesn't already do. If you've got a good answer at what's in the firmware, let me know. Matthew said, for momentary, I assume momentary switches, I mean the physical switch, I want something that shows the current state of the switch, even if controlled by IoT. I think this is a really interesting discussion because you're trying to marry the physical state of the switch to the digital state of the light. Now, if people listen to this going, what the hell are you talking about? You know, like a normal rocker switch, no IoT. When the rock, let's say when the rocker's up, for example, the light is on, and when the rocker's down, the light is off. And you can eyeball the switch, and you know immediately whether, without looking at the ceiling, whether the light's on or off. But if you've got a physical rocker and then you've got a digital toggle, then the physical switch isn't changing when the state of the light changes. So you can effectively get like out of phase. So this is the reason I got momentary switches, just push buttons. But there's a UX aspect to that I just don't like. But unless you're physically moving the switch as well, or they're digital with some sort of a light or something, then I don't like lights behind switches a lot of the time. So yeah, I agree with you, Matthew. If you have any great ideas on that, let me know. Josh says, what do you mean by Pwned 4 or Pwned 5? Is that the name you give products? Yeah, so just to fill in the gaps there, if you go to haveibeenpwned.com and you go to API and you go to API key, you will see that there are 4 levels of subscription based on either the rate at which you want to query the API or the size of your domains if you're doing domain searches. And you'll see they go Pwned 1, which starts at $3.95 a month, all up to 4. So 5 sits on the end of that, and it just doubles everything on 4 and adds the ability to search Stealer logs by website domain if you can demonstrate control of the domain. So that's it. Matthew says, I'm looking at Hager Finesse Press Mix. Yeah, so that's one of the ones we have coming. So the Sparky was quite keen on Hager Finesse. We've got Clipsal, Sat and Zen at the moment, which are absolute rat shit. They're the worst I cannot express how much I dislike these switches. Even like the number of face plates on them in our house, and we've only let's say we've got maybe a dozen of them. The number of them that are held on by blue tack now, because when you remove them, the clips break. It's just ridiculous, and the mechs are terrible. They're terrible. I'll let you know how I go at the Hager Finesse. So that's coming probably next week. I think we'll have one of those as a test switch in somewhere. And then there's a couple of others as well. One of them we are trying, which is IoT enabled. In fact, it's a Zigbee IoT enabled switch. So we'll see how that goes. James says ESP Home and Tesmotor. Okay, Tesmotor is what I was thinking of. You might not need anything extra now, but it's nice to future-proof for stuff that can run open firmware if they aren't supported later. Yeah. But then I think I actually think the future-proofing aspect is the abstraction of the physical switch from the digital implementation. Because if we had that, then you can always change the digital implementation later, but then you end up with a spaghetti of wires and Shellys and stuff in your wall behind it. Wayne wants a Troy Hunt HOVP Discord server. Don't need another thing to do. Speaking of things to do, the final note here is that we are now getting very refined in our Have I Been Pwned rebrand. We've got a logo, which I think is great, that's working really well. We have a dedicated resource rebuilding the front end for Have I Been Pwned. I think it looks fantastic. And I reckon that we're maybe a couple of weeks out from probably open sourcing the repository where he's doing the front end work, inviting people in to come and have a look, make improvements. We've ended up going down the Bootstrap 5 route. I was asking questions about that. I remember where I was. I was on the plane flying back from Europe asking questions about this. So it would have been late December. So that's the direction we've gone. Really happy with the way it's looking. We've also got a proper designer. This is what happens when you start charging money for stuff. You've got money to spend, making it better. So we've got a proper designer who's done the brand and is now doing things like stickers and swag and stuff like that. So we might not have a Discord server, but we've got some other cool stuff coming. Matthew likes the separation of switch and Shelley. Lazy to repurpose switches for another action. Yeah, everything is a trade-off. The trade-off is the other. What does Sparky say in the text message? The other. What's his name? The other switch that we're trying, which is an IoT-enabled switch. I can't find it. I've got so many messages with the Sparky here. One of the nice things about it, even Sparky was saying, rather than, let's say you got like a 5-gang switch is about the worst we have. You end up with so many wires at the back of each mech and then a Shelley on each one, and you just pull it out of the wall and you're like, my God, like what is going on here? If you have it built into the switch, he was making the point that they've got nice little, there's almost like little junction boxes where all the wires just go in the top, and it's neat and it's clean and it's tidy. And yes, it's behind the wall, but if you're changing stuff and mucking around with it, it looks so nice. So I'll let you know what they are. They'll have to come next week. James says, I do like having something like Zigbee as a firewall from the internet. I don't worry about firmware on those devices. I mean, yeah, there's a lot of nice things about Zigbee. Wayne's excited, I think, about our branding. Matthew, I want to keep the physical the same as the digital, but allow for things like press and hold or double tap. Yep, I understand. Neil says, Lutron does good, but I think they're US only and expensive. Yeah, and I did look at Lutron when I went through this first round of stuff, but I think one of the things I didn't like about Lutron is I just didn't like the look of them. I didn't think it was right for our house. And then you're stuck with a physical compromise in order to do the digital thing, which just felt a bit counterintuitive. All right, folks, I'm going to wrap it up there. I've got to go to the airport. I noticed I've just got an email from a journalist confirming a story is now live about a data breach, which I now need to load as soon as I get to the airport. So look out for that one if you like spyware. Little teaser. All right, folks, see you soon.